Welcome to our explainer. Today, we are diving into what might be the most important competition of our lifetime, the global race to build the world's first artificial general intelligence, or AGI. It's a huge deal. So, who's got what it takes and who's going to get there first? Let's get into it.
So here's how we're going to break it all down today. First, we'll set the stage with the next AI revolution. Then, we'll look at the 4 key ingredients you absolutely need to build an AGI. From there, we'll size up the 2 superpowers, check out the strong contenders, and even the unique innovators. And finally, we'll try to answer the big question, who's really poised to win this thing?
All right, let's jump right in. To really understand the race, we first need to get a good look at the racetrack itself.
You know, the whole story of AI is usually broken down into 3 big stages. Right now, we are firmly in the era of ANI, or artificial narrow intelligence. Think about things like ChatGPT. It's amazing, for sure, but it's designed for very specific, narrow jobs. The next huge leap, the one everyone's racing towards, is AGI, or artificial general intelligence, and way down the line is the theoretical ASI, artificial superintelligence. But for today, that middle step, AGI, is the finish line everyone is sprinting for.
So, what is this grand prize they're all chasing? Well, AGI isn't just a slightly smarter version of the AI we have today. Not at all. Think of it like this. Today's AI is a world-class chef who can only cook Italian food. An AGI, on the other hand, would be a chef that could instantly master every single cuisine on the planet, invent entirely new ones on the fly, and then probably redesign the whole kitchen from the ground up just for fun. That's the game changer everyone is after.
Okay, but how on earth do you actually build one of these things? Turns out, it's not just about having a great idea. You need a very specific recipe with 4 absolutely crucial ingredients.
The best way to think about it is like a 4-legged stool. First, you need capital. And I'm not talking about a few $1,000,000. We're talking tens, maybe even hundreds of billions. Second, you need compute. Just warehouses packed with powerful computer chips and the unbelievable amount of energy to keep them running. Third, you need talent. Literally the smartest AI minds in the world. And last but not least, you need a national strategy. A big, government-backed plan to pull all of this together. If you're missing even one of those legs, the whole thing just tips right over.
Now, when you lay out those 4 requirements, 2 countries immediately jump off the page, and they are locked in an incredible head-to-head fight for the top spot.
The US and China are taking completely different roads to get to the same destination. In the United States, the whole thing is being driven by private companies. You've got tech giants like Google and OpenAI building everything from the ground up, from the chips to the software. China, on the other hand, is all about a massive state-led strategy. They're pouring in huge amounts of capital, using their giant pools of data, and working like crazy to build their own chips to get around international sanctions.
So that begs the question, right? With these 2 giants going at it, can anyone else even hope to compete? Well, the answer is a resounding yes. It is definitely not just a 2-horse race.
Let's talk about the strong contenders. These are the middle power countries that have some serious ambition and really smart strategies to keep the leaders looking over their shoulders. First off, you've got the UK. It's been a research heavyweight for a long time, and of course, it's home to pioneers like Google DeepMind. Then, if we switch from brain power to raw financial power, you have the UAE and Saudi Arabia. They are literally turning oil money into compute power, pouring over $100 billion into massive AI projects. And finally, you absolutely cannot forget about human talent. India has the #1 AI skill penetration rate in the world, which means it's in the perfect spot to dominate how AGI is actually used and implemented once it exists.
But hey, winning this race isn't always about who has the most cash or the most chips. There's another group of countries, the dark horses, that aren't betting on brute force, they're betting on a breakthrough.
These guys are playing a totally different game. Instead of trying to outspend everyone, they're trying to outsmart them. Take Japan. They're tackling the massive energy problem head-on, developing new kinds of optical computing that could slash power needs. Then there's France, with companies like Mistral AI, which is all about open-source, super-efficient models. And you have to mention Canada, which just continues to be a giant in fundamental research, building on the legacy of the people who basically invented modern AI.
Okay, so we've met the players, we've seen their strategies. Now let's put it all together and really analyze where things stand right now.
This chart right here makes one thing painfully clear. If this race is all about money and power, and right now it kind of is, then there are really only 3 teams playing in the big leagues. The US, China, and the Gulf states are just on another level when it comes to capital and energy.
You just can't overstate that brute force advantage.
So here it is, the full report card, and it tells such a fascinating story, full of trade-offs. The US is an absolute monster when it comes to talent and private capital. But check out China. It might be a little behind on compute, but it's leading the pack with its national strategy and energy supply. And then you've got the Gulf states, who are the undisputed kings of resources, topping the charts in both capital and energy. It's so clear that no single country has a perfect score across the board.
So what's the final verdict? Well, for right now, the US is still the front runner. But this race is far, far from over. The current approach of just building bigger and bigger models is starting to hit a wall, a literal physical wall of how much energy we can use. And that's exactly where a dark horse could come from out of nowhere. A breakthrough in efficiency, something like Japan's optical computing, could make the whole brute force strategy look old-fashioned overnight. The entire game could flip in an instant.
And that really leaves us with the ultimate question, doesn't it? Is AGI going to be built by sheer brute force, just throwing endless money and power at the problem? Or will a clever breakthrough, a moment of pure genius and efficiency, be what gets us across the finish line first? The answer to that is going to define our future.